Okay, good morning, good afternoon, good evening, depending on when you listen to this voice note. Now, there are about a few modules in the Cisco CyberOps training that's meant to be a networking revision because you cannot work in the SOC center without understanding networking. So, there are some short modules that will brush you up in networking. So, if you don't have a very solid background in networking, this will suffice for you. So the first one we're going to be looking at in the series is the network protocol. So what's our objective? We want to be able to explain, you see, that's why you see most of these things here are explained. You just need to understand because if you understand why you're trying to do your network vulnerability assessment or most of the things that you're going to be doing that has to do with cloud, you're able to better understand how devices communicate. And of course, what protocols they do connect on and at what layer, for instance, in the OSI model. Network communication process. So networks vary in sizes. So the question is, what is a network? You have two or more devices connected to share resources. Now, when you say resources, what do you mean by resources? So resources is not just when you share internet. No, internet is just one of such resources that you share. The other resources that you can share on a network, you can have hardware, you can share CD-ROM, you can share hard disks, you can share what's it called? IP cameras, you can share files, you can share folders, you can share several things on your network, and of course, internet. So a network is two, three systems trying to share resources, and you have several types. It can be peer-to-peer network. So when you just do a peer-to-peer network between two systems or two laptops, it can be a small home network. So most of these things are what you have in Cisco IT or CCNA one. So this is more or less like a refresher for most of us that have forgotten these things, and you want to get into cybersecurity. So you have the small home, the SOHO, the medium large, and the worldwide network. So the www we say is the biggest network. So the internet is the network of networks, right? So what do you call internet? Many systems, many servers all connected together to share resources, information, and the rest. Okay, client server communications. I explained this in the previous module where we're doing module 4, that is Linux. So you have different types of clients. So you have web clients, that's your web browser. You have file clients, so it might be maybe your FileZilla trying to make transfer of files. You can have email clients like your Google Mail or your Outlook. These are softwares that you can use to run that. And of course, you have your email server, your web server, and your file server. So a file server will be able to connect to a file client will be able to connect to a file server. A web client like your browser will be able to connect to a web server. An email client like Outlook will be able to connect to the Google servers or your hosting email servers. Typical sessions. So a typical network uses normally typical network users normally use some type of computing devices. So at school, what are they going to be using? Laptops and tablets to learn. Terry or anybody by name Maxwell, James, Amina, Raji connect to the school through Wi-Fi, right? Of course, they are going to be connected to an ISP so they can be able to search and get online. While gaming, you're going to need high speed internet or connected to a cable TV. You need high speed internet to play games online. So these are common examples where you need to use a network in medical consultations, remote, um, or what they call telemedicine, right? Where somebody have to connect to another doctor for assistance and the rest. Or you scan a result and do get imaging and transfer to somebody else elsewhere to do analysis and give you back the results. Tracing path. So there's a command in Windows which we call traceat. We want to know how many routers, how many networks do we have between our point and where we are connected to. For instance, this is a lab. If you say, if you go to your, if you go search on your search bar and you type CMD, you get to the command line interface. Once you are there, you have something like this, and you type traceat startupventures.com. So what do you have at the end of the day? It gives you how many hops. So this is what a hop looks like. This is a hop. This is a hop. This is a hop. This is a hop. And what do you call a router? A router is that device that connects more than one network together. So normally the Wi-Fi router you have at home might be internet enabled. So it's going to be connecting your internal network at home, either via wireless or via a LAN, a switch, to an outside network that your ISP gives to you. So if you run this command, you're able to know how many hops you have between your own network and where the Southtech Venture server is seated. Communication protocols. So what do you call a protocol? Just a means of communication. Communications have to be defined. How do we communicate? When do we communicate? How do we encode? How do we decode? So you have network protocols. We've listed so many earlier on. Then for transmission of data, it's going to have this structure. Your IP address tells where that information is coming from and where it's going to. It's going to carry that message. Then it's going to also carry the data. So that whoever that's going to receive it knows where it's coming from and if it's actually meant for him or her. Part sharing. You're going to do this and understand this far, far, far more if you do the Cisco CCNA3, which is Enterprise Networking, Security, and Automation. But for now, all you just need to understand is that these routers, they are going to share paths so that they know which is the fastest distance or which way is best for communication. It's like you have 10 persons. If you need to pass information, everybody needs to communicate to know where that data needs to pass through so you can get to the right destination. Okay, so that's that. So you see, this is very, very important. I would love you to look at this guy, right, in great details. So this is what you call your TCP IP suite. And this is the OSI model. So if I were you, I'll do a little bit more research because this is networking actually. But when you use some of these SOC tools, you're going to be seeing most of these protocols. So if you see the protocols, you should be able to know what is actually using the protocols. Good enough, look at this diagram, very explicit. You have web services and web services. This is what they used. So if you're building an application and you're a developer, you're going to be hearing things like REST API. You're going to be hearing things like SOAP API. You're going to be hearing things like endpoints of an API. If you are browsing, you're going to be hearing things like HTTP and HTTPS. Same thing if you're going to be doing file transfer. If you are configuring your email, if you have a host configuration, if you have a name server, all of these guys are on my application layer. It's applications that can use these guys. Whereas these guys is networks that can use between here and here. Then of course, this guy is my hardware most of the times. You see, I mentioned about CCNA3. So that's when you understand these routing protocols. So if you learn Cisco networking, or rather the CCNA 2 and CCNA 3, that's when you go deep into these routing protocols. But for now, you just need to understand the OSI model. I use this for my students because I love potatoes a lot. So, okay, I'll clean this up. I start from down. Please do not take sweet potatoes alone, right? So I want to duplicate this. Just have it like this. Yes, I want to duplicate this. So this is my synonym for physical layer. Well, let me make it this way. Let me start from top. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, why you big? Getting the shape, boy. Then physical layer. Yes. So this is what you call the OSI model, but it's been compressed here into what we call the TCP/IP suite. So these layers, three of it up, it's merged into this. Because of that, this happens at your application. A classical example of session is that, for instance, you have your mobile app, and maybe it's your banking app. You were sent $10 million. So you said, I need to check what my balance is like. You log into your banking app. If you log into your banking app, after some time of inactivity, you're logged out. That's period between when you logged in and when you were logged out automatically. That is a session. So all of that happens at the application layer. Transport is this guy here. So you have two types of connections. Connection-based connection, where we have our three-way handshake, and connectionless. So there are protocols, there are applications of connectionless protocol, for instance, video games, online streaming, teleconference, and the rest. Whereas connection-based connection, where we need to have our three-way handshake, applications are like web, email, and the rest. So you want to understand this OSI model and see the applications, please. Okay, so these are some other additional protocols. I've explained DHCP. I've explained most of this in module 4, the SMTP, POP, IMAP, and the rest. I've explained most of this. So this is where you have connection-based connection and connectionless based connection. So this is called TCP, this is called UDP. Okay, the question is, we're trying to understand communication protocols. Very important, you should understand that IP version 4 is a 2-bit, IP version 6 is 128-bit, and NAT is what helps us to keep using IP versions 4. IP version 4, let's say 192.168.192.168.8.5 is an example of an IP version 6.4 address. Then when you have a very long string, it's an example of your IP version 6 address. It's because it's 128-bit. MAC address is 48 bits. Take note of that, please. NAT is what helps us to translate between your internal network that your router gives to you to your switch, or rather, yes, your router gives to you, and to your external IP address. Take for instance, you have a network, a LAN. This person have 192.168.8.1, 8.2.3.4. Everybody have the IP address. If everybody is connected to the internet and each person goes to Google and type my IP address, you're going to see your public IP address. Whereas the one your router assigns to you is what you call your local IP address. And of course, another address which you call the loop back address, which is 127.0.0.1, which you can still refer to as your local host. Most of the times when you install a local environment, a local server within your operating system. Okay, so for messaging, so these explanations, and for routing protocols, ARP works together with DHCP to assign IP address. I did a great detail of explanation when we are considering the Cisco IT training, right? When you get to access a router or a device, ARP, the protocol is going to try to resolve an IP address for you, right? Explain that in detail. So you want to understand encapsulation and de-encapsulation. I think there's a short video here on the LMS. Please watch this video, it's very detailed. It explains how items goes through the OSI model. Yes. For instance, if this is a PC and this is a PC, and don't worry, this has the exact thing that you have here. You send a mail, it will go down till it hits the router, the switches, the hardware, gets into the other network, the physical, whatever, the next person opens his browser and can now view the application. That's an example of what this video is trying to explain to you. Please log on to your LMS. It's a very short video and you watch it. Take your notes, please. If you have questions, don't forget to ask on the platform. Okay, so this just explains what happens in a network. Message size. There's a short video here telling you how people communicate. Please watch it. It will help you, and most of the things I'm explaining to make it understand better. Message timing. So flow control, response time, access method. Right? Please watch this video. It's going to get you understand how devices connect on a network. And there's what we call the unicast, the multicast, and the broadcast. In your LMS, there are three short videos. Most of them are not more than 1 or 2 minutes. It's good you watch them. They're going to simulate what a unicast looks like, what a multicast looks like, and what a broadcast looks like. For instance, for a unicast, you send packet of data just from this guy to one person, this guy to many, this guy to all, right? So that's the difference between a unicast, multicast, and broadcast. Of course, the names are even very self-explanatory. Okay, I think this is what I was trying to explain earlier on. This guy here. Let me zoom it out. Okay, great. Let me take this off. Okay. This is fine. We can all see. Let me take this off. Take this off. Take this off. Yes, so I have this. So you have the OSI model is a little bit older, but you need it to be able to understand these layers. TCP/IP protocol suite and the TCP/IP model. So these are the protocols you have within this layer. If I ask you, for instance, a router is what device? Is a network device. That's what does all of this. A switch is a layer 2 device. That's why a switch cannot assign IP address. It's a router that assigns IP address. Right? That's why a router can give you an IP version 4 and IP version 6 address. Imagine somebody I still asked a question a while ago. I think this should be a very long time now. The question was that I want to know my IP address. So the question I asked back was, are you on a network? And the only way you can be on a network that is routed is if you're connected to a router. So that's the only way you can be assigned an IP address, right? That's when you can be assigned an IP address, except you're using a layer 3 switch. So a switch is a layer 2 device. Then, so this is the summary. All of this is all bundled up to application. So this is like a model. These are the suite, the protocols. Then these are the model. A networking model is only a representation of a network operation. The model is not the actual network. So this just tells you how communications are done, right? Okay, let me undo most of these changes I made. Okay. The OSI, the meaning of that is open system interconnection. Okay, so this is it. So this explains all of the things I've been saying all the while. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, so this is the TCP model. It breaks it down into now 4 areas and explains them. Data encapsulation. So for me to receive encapsulation, I mean to say, for me to receive data, the data have to be segmented, have to be broken in pieces, right? So if large streams of data is sent across a network, it will result in delays. So that's why segmentation is the process of dividing a stream of data into smaller units for transmission over the network, right? So it helps to increase speed, increase efficiency, and at times they have to be given sequence number, right? So you go first depending on order of priority. That's what we call quality of service, QoS. So it's written this way, QoS, quality of service. So most routers, they give you that option when you are configuring them, how to decide quality of service. Which protocol do you want to give higher priority? Which protocol do you want to give priority? For instance, if you give UDP higher protocol, it then means that you're able to stream faster, whatever. If you give HTTP, if you give a particular protocol more priority, then it will assign more bandwidth to that particular device. So that's just a classical example of sequencing. Protocol data unit. So that's like your way, the way in which small piece of data that you can use to transmit this data. Okay, so what do I need to explain here to you? Anything that's going to give you a tough time? So PDUs for each form of data are the data, the segment, the packet, the frame, the bits. So this is an explanation of if I have an email data, for instance, it's going to have all of these guys, right? So bits, so this is a representation, the frame, all of this, it's going to carry all of this information. The packet is going to take all of this. The segment is going to take all of this. The data itself is going to take all of this and to pass it down the stack, right? Down the layer in the OSI model. Okay, so I think I've explained this earlier on. You have two guys, so if this is going to communicate to this guy, so it's going to come from this way or through this way up. So encapsulation and de-encapsulation. There's a nice video in the LMS. Please, you do well to watch it. It's like a simulation video. Same thing with the encapsulation. So encapsulation is where you are okay, let me use this example. Just a moment. I'm sending an email. It leaves my system. It gets to this layer, presentation. How will that data be presented? Right? Am I going to be using HTTP? I'm going to be using HTTPS or whatever. Or is it going to be MP4 or 3GP or whatever? It gets to session, get to transport, get to my network. What kind of network am I using? Of course, this guy gives it IP address, gives it some packets, some rather some frame data. It gets to my switch, gets to my hardware, leaves my network, gets into the next network based on the information that it has here. If it's meant for this network, it gets into the network and start getting to the PC. That will up till it cannot be viewed here. So this is here I'm going to be encapsulating, 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 encapsulating. Let's say I have one shirt. I have two shirts. I'm going to be wearing two shirts, three shirts, four shirts, five shirts, six shirts, seven shirts. Here, I'll pull up one shirt and I have six shirts here. So that information between these guys, I'll pull it up, understand it, and I drop it. This is like, I just remembered something. You know, when you want to launch a rocket, it's going to have so many things encapsulated into the body, the frame of the rocket. By the time you launch the rocket, or by the time you launch the missile, or by the time you launch the space mission, as it shoots into the firmament, shoots into the airspace, shoots into get out of planet Earth into space, it's going to be shedding and shedding and shedding and shedding and shedding all of that, right? So that is when you now keep going up. But why when you are building, you add up, add up, add up, add up. And when you are trying to now read the data, so you have to remove everything, read it up, remove, read it up, remove, read it up. At the end of the day, you now have that same data that you had here. So that is encapsulation. This is de-encapsulation. Okay, so that is encapsulation here. So you can watch that short video to make you understand more. And this is de-encapsulation. So the encapsulation is the process of used by a receiving device to remove one of the protocol headers. So you remove it so that you can see what information is there and you pass it up to the next layer. Okay, in a lab later on, we're going to be using Wireshark to demonstrate most of these things. Okay, that's summary for module 5. Thank you very much for listening and see you in module 6.